Hey folks, this is Kyle, and today I'm going to show you how to create a small-scale fluid simulation in Cinema4D using the native particle system. And I would say that I've been exploring for a little bit, and I think it is best for these small-scale, high surface tension, high viscosity type scenarios. So if you're trying to do some sort of larger scale fluid effects, this is not the right tool. And if you have ever used pop fluids or vellum fluids in Houdini, this is somewhat similar to that. It's more simple, but I think that can be approachable for people getting into these kind of fluid simulations. So yeah, let's dive right in. This is the cached version that is from the post I did on Instagram. Let me adjust my safe frames. Cool. So yeah, this is what that looks like. The cool thing is you can see the particles are not so dense, but they're still holding their shape really well. So that's one thing I like about this simulation with the Cinema4D's particles, because then when we go to create a mesh, you can see that it holds its shape really well around these particles, right? And it's forming a really nice fluid mesh around those. Cool. So yeah, that's what we're going to be doing, and let's get started. Okay, first things first, I'm going to turn off the cache mode, so we're just going to be seeing the real playback speed, which is still not terrible. And so I have set up a basic emitter. So this is a circle. I changed the shape here from rectangle to circle. And let me turn off the forces for now. Cool. So we just have like a shockwave, I guess. And that's a result of changing the initial velocity here from whatever the normal direction of the geometry to just radial. And since it's a circle, we just have a flat radial expansion at a speed of 200 and a variance of 50. I haven't changed any of these other settings, so we're just going to have a radial burst is what I wanted. And then to make it more interesting, forces come into play, right? So first thing we have is turbulence to break up the uniformity of the expansion and add some unpredictable movement to the simulation as a whole. You could add a large scale and a small scale turbulence, really whatever you want. These are the values for this one, pretty high scale from where it starts at 0, so yeah. And then a rotation force. So they are rotating this direction. Like if this was pointing straight up, they're rotating around it. Cool. Friction slows down the simulation, so that's something that we want for these kind of small scale, sticky fluid simulation. We want everything to be kind of losing energy. And that will help, especially once we enable flocking, which is kind of the bread and butter of this effect. So I've changed let's see. So the defaults are these values, and I've changed them to increase the global strength, the strength of the adhesion, the collision or cohesion radius, and the separation strength is default. So just really playing with the cohesion strength and radius, which this radius is telling the particles how far to look at other particles to grab them and stick with them, right? So the farther you increase this, the farther the particles are going to look for other particles to grab onto and stick together with. So if, and in my emitter, it's at 100,000 because it's just the first frame is shooting out this amount, and I can reduce this to increase the speed of our visualization. And you can see with these forces and this setup, we already get kind of the effect that we're looking for, these small scale fluid type droplets. And yeah, one thing that I also I did change was the color. So this is a really straightforward just way to set the color of the particles initially. You can also change them over time or using a variety of attributes or properties with the color mapper. I didn't need to do that, or didn't really want to do that for this one. I didn't even know if I was going to use the particles in rendering. So, but you can modify the color with a lot of flexibility using the color mapper and using the color here which is just set with a noise. And you can modify the parameters here. So that's how the color is set. Cool. And so the more particles we have, the better representation we're going to have of the fluid surface. So having a high number here is sort of important, but even if you have a low number, let's see how this meshes. So it still meshes pretty well. So that's one thing, again, like I think is really good about this system, is how it keeps these particles separated at an even distance, so that the meshing works really well. So if let's turn this down to whatever. Okay, it's 5 by default. Let's see what that looks like. So you can see this. I mean, I think there's just a ton of cool possibilities, and I'll continue to experiment with this system, especially the flocking and some of these other forces. But you can see this breaks it up at a pretty small scale, even probably too small for what we're going for, which is like a macro small scale fluid look. So we want those big goopy droplets. So yeah, literally I just increased this to an amount that I thought represented that scale properly. So you can play with these. You can play with the separation strength as well. That's what's pushing them apart. So this is the distance they're being kept apart. And yeah, you can see that changes the whole look of everything too. So a lot of flexibility with just changing a few parameters. It would be cool if there was some sort of like wedging feature, which essentially just means being able to run the simulation multiple times or cache it multiple times with random values for some of these, so that you wouldn't have to just keep running it over and over again while tweaking the numbers manually. But it is what it is. Cool. So in the properties, the radius is just default at 1 centimeter. So when we bring this into the volume builder, this is what it's going to look like. But I have added a smoothing, and I've reduced the voxel size to 2 and set the radius. You have to set the radius of the particles, or you can use the size that that's being mapped to them in the sim itself. So you could have that changing over time if you want to. This again is a really just simple example using mostly default values for things. So if I increase this, it's going to get bigger and bigger, make it smaller, etc. So 8 is a value that I found that worked pretty well for this situation, and then smoothed it to get a nicer mesh. You can see it's not even that high quality. So, but for this, I think we wanted it a little smoother, not as like a perfect representation, but a smoothed out representation of what we got, and we get the overall shape, which is what we need. So we'll then throw that in the fluid mesher, and that is what it looks like. And once we throw some materials on there and whatever, it's gonna look pretty good. And again, yeah, this is with just a pretty low number of particles, and you can see the fluid behavior is pretty nice, even though this is not a fluid solver, really, I don't think. So let's bump that back up to 100,000. If you're trying to run the mesher and everything in real time, it's going to be slow, but still not that slow. Yeah, and just some really nice tendrils and small things you would expect from a high surface tension fluid, which, yeah, I think is really cool that we can do this now in Cinema4D without going somewhere else. Cool. And then, yeah, just some dome lights and area lights I set up, and a couple camera angles, one really close up with some depth of field and one farther away. So if you don't change anything, the particles will render. The particle group will render at the radius that you have it set to in the emitter or the particle group. And you can change that like we talked about, but you don't have to do anything additional. If you want to, you can also use a cloner and use the particle group as the object to clone things onto here, and make sure that the size of whatever you're using is set to 1 if you want them to match the size of your particles. And you can scale them to be the same as your particle scale. So let's hide this, make these multi-instant so it's a little faster. And then we can also scale them as much as we want to. So we have, objects we can use instead of the defaults. And this could be anything. Any object could be cloned on here. And you can also, cool thing is then you can also use your normal whatever effectors you would want to use in this situation. Yeah, so that's cool too. But let's get back our particles, and then let's turn on our fluid mesh. So literally for the particles, I didn't have a material. In this one, I just had one transmission material with a lower roughness value. And then I used the background in the post effects and have a dome light that is, I think, in the asset browser, and then a couple area lights as well that are just targeted towards the center. So that is pretty much everything about this one. Yeah, I mean, I think there's a lot of potential in this type of setup. So I'm going to keep exploring. Please, yeah, show me whatever explorations you do. And yeah, that's it for this one. I will catch you later. Peace.